Yes. Good evening, my dear friends. Welcome to the session once again. Biogeography Part 2. Under this biogeography, we will be dealing with soil, plant and animal distribution. Yesterday we have already finished the part 1. Today is the second part. Clear? We'll wait for some more learners to join in. After that, we will continue. Come on, quickly join, my dear friends. Yes, kindly join. And if you have any doubt regarding any section that we have discussed yesterday, you can always come up with the doubt. I will try to resolve it. On the other hand, the only mode of communication that we can do under this YouTube is in the live chat box below. So in the course of discussion, if any one of you, if you have any doubt, you can interrupt me at any point of time. Okay. I will try to address that particular issue that you will have. Yes. And also, I have special classes in Unacademy platform where we are discussing geography of India or Indian geography through map. Okay. Which is completely free, 100% free. You can come and join me there. Also in Unacademy platform, I have a plus course. If you want to study in detail, you can come and join me there as well. In the YouTube session, as you know, we have certain limitations of time as well as limitations of tools of interaction. In Unacademy platform, we have very efficient tool, just like raise hand, or you can ask verbally. The question you can ask verbally to me, we can interact verbally. Okay, so there are many facilities in the Unacademy platform where the session becomes very, very interactive. Clear? Therefore, you can come and join me there in the Unacademy platform. But anyways, as we wait for some more learners to join in, let me just give you some information from the Unacademy platform. Resolution to crack this UPSC 2023. The roadmap is 2023. There is a introductory offer, that is extra 10% off you will get, and also you will get 3 months of free extension. That is 18 months combo pact you will get in 70,999. You are saving around 8,000. It is valid only till 12th of January. Additional benefit that you will get is you will get books, especially curated and written for UPSC, GS books. You will get 3 months extension. Along with it, it is blocked by me, but behind me there is another important scheme, that is a facility or benefit, that is the test series that you will be able to attend. Clear? Now, your prelims is very near. It is in the month of June. Prelims 2022. Taking this into consideration, the Unacademy platform has come up with a comprehensive batch course on GS. It is starting on 12th of this month. You can kindly enroll for this. Also, you can enroll for 2023 if your roadmap of appearing for this exam is in the year 2023. Clear? One of the benefit that you will get out of this session is you will get 20 GS book. Okay. Optional courses are launching this month, such as BSIR, History, Sociology, Public Administration, Economic, Geography, okay, Philosophy. Kindly enroll. As you know, there is a UPSC CSE compact, that is a 56 multiple MCQ, that is multiple choice question will be there to be solved in 60 minutes. It happens every Sunday in Unacademy platform. So this coming Sunday, that is 9th of January, 11 AM, you have this. Now, You lose nothing, you only gain. There are only few things in the world where you lose nothing and you gain, and this is one of those. Okay, why? Because you see here, by appearing such a test, that is MCQ, in the form of compact, you will know at what level of preparation you are. Self-assessment, you will get a chance for self-assessment. That is very, very important as far as the nature of a competitive exam is concerned. Why? Because it is no longer, okay, a university or a college exam. You don't have a pass mark. It is a merit-based exam. The other thing is, you will get a scholarship from a pool of around 4 crores of rupees. For all of this, you can use my code, that is SUNEP10 as your enroll code. Clear? With that basic introduction, let us begin our discussion of today. Yesterday, I have started the chapter, that is Biogeography. Yesterday, we have seen some important characteristics of soil, okay, and the importance of the soil itself. Yesterday, we have seen the soil texture. Also, we have seen the soil colloid, which is a very, very important characteristics of a soil. Today, we will continue with the soil color. Okay, soil color. Again, very, very important, the soil color. Now, depends upon the color of a soil. You see, if you identify the color of a soil correctly, there are many things or many characteristics of the soil or properties of the soil that you will come to realize, or you will understand the important characteristics of the soil by just knowing the color of the soil. Now, the color of the soil depends upon what? It depends upon the mineral. Okay, it depends upon the mineral, organic content, and varies according to the presence or absence of iron, aluminium, and humus. Clear? Organic content can be, okay, supplied by the organic matter, that is the plants and animal. The decay of plants and animal, yesterday I have already discussed with you. The organic matter is nothing but the supply from the plants and animals after they decay, decompose, becomes part of the soil. That is the organic content of the soil. Minerals can be supplied by the parent rock, because we have seen the soil is derived from the parent rock by the process of weathering and erosion. So, depending on the minerals, the influence of the parent rock, I can say the presence or the absence or the quantity of this organic content, okay, results in the color of the soil different. Okay, now if the color of the soil is dark, then we can come to a conclusion that it has a very high humus content. What is humus? Humus is the decay of organic matter. So if the color of a soil is dark, we can come to a conclusion, fairly good conclusion, that it is having a very high humus content, means organic content is there. Much nitrogen, okay, and this type of a soil is having a high fertility, whereas light color soil, if the color of the soil is light, then we can come to a conclusion that it is a low humus content, and also the fertility is low because the humus content is low. Clear? Now, if the color of a soil is red and yellow, then it means the oxides and hydroxides of iron is present. Also, the soil is well drained and aerated. Remember this. Yesterday we have seen the soil consists of solid, liquid as well as gas. Soil is not an inert or a passive object or a passive system, but soil is a very active system. Soil exists in the form of solid, liquid and gas, that we have seen yesterday. The solid is nothing but the tiny soil particles combined together, tiny particles combined together to form a soil. It can be sand, the proportion of, during our discussion of the texture, we have already seen that particular triangle, the clay, the sand and the silt, combination of all this resulting in different type of soil. Now, in the spaces which is there between all of these tiny particles, you have liquid, you have gases. So if the soil is well oxygenated or the air is able to circulate efficiently, it is known as a well aerated soil. So if the soil is red and yellow color, you can say that there is a presence of oxide and hydroxide of iron. Also at the same time, they are well drained and well aerated. Now bluish gray. Bluish gray, if the color of the soil is bluish gray, it means it is badly aerated. Means the circulation of the air in the soil is less, or it is not well circulated, the air. And also the iron content is in a reduced state. Okay, means if it is in an oxidized state, see, when it is well aerated, the iron will undergo oxidation resulting in the ferric oxide. But if it is not well aerated, it will be reduced, means reduction will take place. So the iron will be present in a ferrous form. Okay, so if the color of the soil is bluish gray, it is badly aerated and the iron content is in a reduced state because of the exclusion of the oxygen, which means the soil is not well aerated, so the oxygen, or you can say the oxygenation, is also less. And why it is happening? Because the soil is a wet soil, means it is kind of waterlogged condition. Therefore, well oxygenation or aeration is not possible. Therefore, the iron content turns into the ferrous reduction, resulting in the color of soil to be bluish gray. If it is oxidized because of well aerated, it becomes red and yellow. Okay, now as I told you, by knowing the color of the soil, we will be able to know some important characteristics of the soil. That is the importance of this soil color. And this soil color is determined by a chart known as a Munsell color chart. Clear? Now, let us go and see another important characteristic, that is the lime content. Important characteristics of a soil. Okay, lime content. The content of a lime in a soil is also a very, very important characteristic of the soil, because it determines some important characteristics of the soil. Lime is very soluble in region of persistent rain, where there is a high precipitation. It is leached from the surface layer, this lime content. Why? Because lime is highly soluble. Therefore, on the surface, if there is a high rainfall, since the lime is quite soluble, it is dissolved and it is leached from the surface of the soil and percolated downward. Depending on whether a soil accumulates lime or not, the soil is categorized as petalous and petalsphere. Petalous is one where you have alkaline type of a soil. That is alkaline type of a soil. And if the soil is a petalsphere, depending on the accumulation of the lime or presence or absence of the lime, the soil can be classified as petalous and petalsphere. Petalsphere will happen in a region, or you will find a petalsphere type of a soil in a region of a heavy rainfall, where the rain takes away all the or most of the material, leaving behind on the surface oxides of iron and aluminium. Because they are heavy, they are not leached down, resulting in a type of a soil which is known as petalsphere. But in a region where you have lime content, you call it petalous. They are alkaline in nature and they are of high fertility. Okay. Now, pH value. That is the acidity of a soil. pH value. See, the soil, some soil are classified as acidic, some soil are classified as basic. the acidity of the soil, that is whether it is an acidic soil or a basic soil, is measured by this pH value. So you have this pH scale of the soil ranging from, say for example, 1 to 14. Okay, now lower down the scale, 1, 2, 3, like this, lower down the scale, the soil is acidic. If the soil pH value is towards this lower level, it is a acidic soil. If it is on the higher side like 14, 13, 12, it is known as a basic soil. In between, around 6 or 7 or 7.5, it is known as a neutral soil. Okay, now you take one sample of a soil, you determine the pH value. If the pH value is on the lower side, then it is an acidic soil. Say for example, if I have 5, I have 4. If I have one soil that comes under this category 4, one soil that comes under this category 2, then this soil which comes under this category will be more acidic as compared to this type of a soil. Similarly, the basic on the higher scale. So the neutral soil is in between 6 to 7 or 7.5, or you can say 7. Clear? Now the measurement of this pH value of the soil is done by the whether the presence or absence or the concentration of these hydrogen ions. You go and determine, okay, you go and collect a soil sample, you determine, you try to find out the concentration of this hydrogen ion. Hydrogen ion is acidic in nature, okay. So the concentration of the hydrogen ions will determine whether this particular soil is acidic or basic. Say for example, let us take the example of this sandy soil. With poor heat vegetation, means where the vegetation is very less, it will have a very low pH value. Low pH value means pH, this is pH scale, okay. This is a pH scale. Therefore, low pH means it is acidic soil. So a sandy soil is an acidic soil because it is having a low pH value. Acidic because the compound of calcium, magnesium and potassium, which are essential nutrients for plant growth, are easily dissolved away by water percolating through the soil. In a sandy soil, these bases, okay, we call it as a basis also. Calcium, magnesium, potassium, we call it as a basis also. These are easily washed away or dissolved away by the water in the sandy soil, resulting the soil to be acidic in nature. Why? Because the basic are removed. Soft calcareous rock are often naturally very, very fertile because the rate of weathering of the calcium, okay, weathering of the calcium in the parent rock is sufficient to replace the loss of leaching of exchangeable calcium. Clear? Now, let us quickly go ahead. The soil horizon, that is, in the last class, yesterday, we have already discussed, if you take a column of a soil, that is known as a soil profile. Okay, soil profile, which means like this. You go and dug a soil. Now, we know that the soil is formed from the parent rock. Okay, from a parent rock it has been formed, the soil, by the weathering and the erosion. Now, the column of a soil will be till you find the parent rock. So from the surface you dug a column till the parent rock, okay, and this particular column of a soil is known as a soil profile, which we have already seen. Now, this particular column of a soil, the thickness or the height of this column of a soil is not similar in all the region. In certain region they are very thick, in certain region they are very small, very little. But as a whole, in general, we will try to analyze. Okay, in general, we will just consider different layers of the soil. Now, in this particular soil profile or column of a soil, this particular column has different layers. different layers, okay, and these layers are known as soil horizon, different horizon of the soil. Let us see one by one. This particular column represents different horizons, okay. Now you see here, the first horizon is, that is the topmost layer of the soil, is A00. Let me tell you once again, this is in general, we are taking this for the sake of explanation. Otherwise, let me tell you, if you go to different part of the world, the soil profile or the column of the soil will be different in different region. But for the sake of explanation, we are taking this as a general understanding of the soil profile and its different horizon. The first horizon, that is the first layer, that is the topmost layer of the soil, is known as A00. Represented by A00, what does it mean? The first or the topmost layer of the soil will consist of loose leaf or organic debris. You see here, if it is the ground surface, okay, I will have this vegetations here, plants. Now these plants will, the leaf will come down from this plant. There may be other organisms also. Yeah, Pratik Dixit, good evening. How are you? Welcome to the session. I hope my audio is audible. We are discussing biogeography. We have started from yesterday. Yesterday was the first session and we are continuing today. Okay. Yesterday was the first session. Today is the second session regarding biogeography. Under biogeography, I will be taking soil and plant and animal characteristics and distribution. That will be covered under this biogeography. Yesterday we have seen some basic characteristics of the soil. That is the soil texture, okay, soil colloids, importance of the soil. Today we are continuing with these characteristics. Yes, I am also doing very, very good. Thanks for asking. I hope, how is your preparations going on? Okay, you can, if you haven't watched my previous video, that is yesterday's video, you can kindly go and see that video. It is available in YouTube. Okay, good. So that you start from the beginning. Okay, yesterday I started this chapter, biogeography. Also at the same time, let me tell you, I am running one course in Unacademy platform, that is a special class in Unacademy platform by the name of Indian Geography True Map or Geography of India True Map. Okay, it is absolutely free. You can come and join me there. We are the timing is from 7:30 to 8:30 in the evening. Okay, every day. So if you're interested, you can come and join here. It is absolutely free. Okay, okay. So anyways, let us continue with our discussion. And also you see here, if you want things like in detail, I have a plus course in Unacademy platform. There also you can come and join me. Now, the point is, see, in YouTube, we have certain limitations. Like the mode of interaction is only through this chat box. Okay, live chat. But in Unacademy platform, we have many good tools. Like raise hand is one option. In this raise hand, you can ask question verbally to me. And I have many tools by which I can explain. Okay, I can use many different tools where I can explain the things very efficiently and in a very interactive manner. Clear? So you can come and join me there. Okay, chalo. Let us continue with our discussion. So the first layer or the topmost layer or horizon is known as A00. I have a plant. The plant will supply the leaf. The leaf that you will find on the ground surface is represented by this A00. Clear? Now, just below this particular plant leaf which falls on the ground surface will undergo decay and decomposition. Therefore, just below the topmost layer, I have the second layer or the horizon, which is known as A0. This A0 is a partially decomposed organic debris that is supplied by the plant. The third layer is known as A1. That is, this partially decomposed organic debris will undergo further decomposition, resulting in the formation of a humus. Therefore, the third layer is a dark color rich in humus. Then comes the fourth layer, that is A2. It is a light color zone of rich colloids and humus. Regarding the colloids, we have already discussed yesterday. Okay, now why this particular A2 layer is light in color? Why? Because from this layer, during the rainfall or when there is a rainfall, this particular substance, the humus and the colloids, are leached down or carried down by the water to the lower region, which we are going to see. Now comes the next layer, that is A3, that is a transitional layer to B. Okay, now B1 is the transitional to A, means this layer will look like a little bit similar. Why? Because they are the boundary condition from one layer to the other. Now comes the main, that is the B2 layer, that is deeper color zone of maximum colloidal accumulation. In a sense, the colloids and the humus which is leached from this A2 layer is supplied to this B layer below. Therefore, this layer becomes deep or dark in color and maximum colloidal accumulation will happen here. If you go down further, the B3 layer is the transitional to C. And what is this C layer? C layer is a clay layer. Okay, clay layer. What is clay? I will explain to you a little bit later now. But the C layer represents the clay layer, and finally the D layer is the solid rock, that is the parent rock. Yesterday we have already seen that the soil formation happens from the parent rock, that is weathering and decomposition. Therefore, the last layer is the D layer. Now, this solid rock, the permeability or the porosity will be less. Okay, means the water will not be able to percolate down very efficiently in this D layer, that is the solid rock over which the soil is formed. Therefore, since in this D layer the water will not be able to percolate very efficiently, a water stagnation will happen. Stagnation of the water will happen. When there is a stagnation of a water, that will happen. Okay, this type of a clay layer will develop. That's why just above this D layer, I have this C layer, and the important characteristics of this C layer is the clay layer. Okay, I hope that is clear. So these are the different layers of the soil: A00, A0, A1, A2, A3, B1, B2, B3, C and D. See, if you go and see different literature or different material regarding the soil horizon, some they club all of this layer together as one layer, all of this layer as another layer. Okay, so in different book you will find different layers, but this is one of the most accepted and easy to understand layer system. Clear? Now, soil forming processes. How the soil is formed. Yesterday until now, we have been talking that a soil is formed from the parent rock by the process of weathering and erosion. Today, let us go and see it in detail. Okay, the soil forming processes. The first one is, it is the weathering. I am not going to explain this again, but why? Because we have already seen this. Translocation, that is, after the weathering of the parent rock, downward movement of the material in solution, okay, or colloidal suspension. Solution means the particles or the material dissolve okay, dissolve in the water and carried from one place to the other, or it can be in suspension, it can be carried from one place to the other. It is known as leaching. Now, whatever it is, the physical downward washing is known as eluviation. Okay, whenever there is a percolation of the material either in the solution form or in the suspended form, if it is carried from one place to the other, from the place where it is removed or percolated down, this layer is known as eluviation layer. Now, this the material which has been carried from this place, taken away, is deposited in another layer. This layer is known as, where it is deposited, it is known as alluvial. That is I here, importing layer. You can just remember by E means export. Something is sending out. That is a place where, or a region where, or a layer where a material is being removed. It is known as eluviation, export. And the place where it is collected, it is known as alluvial, means importing. I stands for importing. Clear? That's why you see here, in this soil horizon, I have written here like this. This part, that is the eluviation, that is sending out something, exporting out, means leaching of the colloid and humus is taking place. And in this B layer, I have written this eluviation, that is importing. Clear? Now, in semi-arid condition, calcification will result. Now, you see here, one of the important characteristics of this soil is whether down leaching will happen. Means leaching means carrying away of material from one region to the other, whether it will happen from top to the bottom, from the surface of the soil to interior or below, or from below or interior to surface of the soil. Okay, transportation or translocation, this will be determined by two processes, that is rainfall, precipitation, or evaporation. In a place where rainfall is much higher than the evaporation, then the leaching will take place. A material will be leached from the top or the surface of the soil to the interior. Whenever there is more in a place, whenever there is more rainfall, leaching will take place. But in a place where the evaporation is much higher as compared to the rainfall, especially in a place like arid and semi-arid region where the rainfall is very less, the evaporation is much higher as compared to the rainfall. In such a situation, because of the capillary action, materials from the interior will be taken out to the surface. That is, calcification is one of those. Now, there salinization, alkalinization, there are two different things that you need to know. That is, salinization is a process where in extreme cases where evaporation is very, very intense, this is due to the capillary rise of the water from a water table that is saline and close to the surface. Salts of sulfate and chloride will be there on the surface. Salts of sulfate and chloride, these are known as salinization. On the other hand, if the salt is of sodium, it is known as alkalization, and it is usually done, or it is usually seen in a place where blown inland from ocean or irrigation, means this salt of sodium is a result either of it is blown inland from the ocean, or because of the irrigation, or because of weathering. Clear? Now, organic changes in the soil. Okay, we are discussing the soil forming processes. One is the weathering of the parent material itself. Second is the translocation. Okay, see, all of this activity results in the formation of soil and giving a soil particular characteristics. Why? Because you go to different part of the world, the soil that you will find is different. Why? Because the soil forming processes which is acting in that particular area, that is the weathering, the translocations are different. Another important process in the soil formation is the organic change. Now you see here, degradation by fungi, algae, worm, etc. Humification of material, that is dark amorphous mass. The humus itself undergoes decomposition, resulting in the mineralization, that is nitrogenous compound into the soil. So the organic changes which is done by algae, worm, fungi, etc. results in the organic change in the soil itself, finally giving rise to a particular characteristics of the soil. Podzolization is another process. It is also known as chiluviation. Okay, podzolization or chiluviation. Now, what is this podzolization? It is very important to know that. You see here, different solubility of various minerals. In the soil we have different minerals. Okay, now depending on the minerals, the solubility varies. Some minerals will be soluble, some minerals may not be soluble. Okay, depending on the condition and the agent. Now there is a chelating agent which are a organic compound found in a conifer needle. You see here, if you consider this as a globe, this is equator. Okay, it is a polar region. You have this tundra region. I assume that you know all of this basic tundra region. Below this or nearby this place you have this coniferous forest region. Important characteristics of a coniferous type of a forest is it has got a leaf in the shape of a needle. Okay, it is some of the adaptive characteristic that has been developed by a vegetation in this area. Why? Because it is very cold. Okay, very cold, strong wind blows. Okay, and snow happens. Therefore, in order to protect the soil itself, the shape of the tree is also cone shape. So even if there is a snowing, the snow is able to fall out very easily, protecting the tree. And also the leaf, it is having a needle shaped leaf, that is the coniferous forest. Okay, now in this type of a forest that is in a very cold climatic condition, near or just next to or very close to this tundra type of vegetation, you will have this coniferous forest. In this coniferous forest, the needle which is in the form of a leaf which is given out by these trees will fall down on the ground surface. It will undergo decomposition, means the bacteria will come, undergo decomposition, but the rate of decomposition will also be very less. Why? Because you see, for chemical action to take place, you need temperature. Here the temperature is also very cold, very less. Therefore, during the process of decomposition of these coniferous needles, that is the leaf of this coniferous tree in the form of needles, the bacteria which is acting on this coniferous or conifer needles give out certain kind of material known as a chelating agent. They give out certain kind of material in the process of decomposition by the bacteria. That is known as chelating agent, which is very acidic in nature. Okay, which is very acidic in nature. Therefore, this particular chelating agent, okay, which is given out by the bacteria while acting on the coniferous needle in the process of decomposition, which is very acidic in nature, they wash down everything. They wash down even the iron which is there in the soil, because the soil will have different minerals. So the iron content in the soil, everything is removed because it has been leached below because of this chelating agent, which is very acidic in nature. Finally, resulting in a silica rich soil. Okay, silica rich soil. You see here, I have a surface here. Now, because of this chelating agent, iron, all the minerals in the soil is leached down because of this chelating agent. But leaving behind the silica on the surface. Therefore, silica-rich soil is acidic in nature, and the appearance or the color is ash-gray in appearance. Okay, clear? Such type of a soil is known as podzolization. Such type of a soil is known as podzol, and the process of this formation of this type of a soil is known as podzolization or diluviation. And this type of a soil you will find in a coniferous forest or in a very cold climatic condition. It is because of the chelating agent. Clear? Very, very important. Okay, this process is podzolization, and it is found in a cold climatic condition, especially in the coniferous forest just next to the or near the tundra region. Clear? Let's end the session here today. We will continue tomorrow. Thank you all for your patience and cooperation. We will continue tomorrow. Clear? Bye bye and good night.